All right, calculus, here's what we're going to do. We're going to try to do a lesson on the fundamental theorem of calculus, part 1. All right, the other day we wrote that on the board. We wrote that definition, I believe, on Friday, so get that from a friend. Anyway, find the derivative of each function. Now again, think of what we're doing. This is g of x. It's an integral. So g of x is the antiderivative of something. And I want to know what g prime of x. I want to know what is the derivative of an antiderivative. So there's a quick way to get this using, again, look at the function. Function's right there. Using the fundamental theorem of calculus part 1. G prime of x would simply be 3x squared minus 2x. Now, we're going to do two examples the long way here. Here's why. So what I know is I can integrate this. I can take the antiderivative, 1 power up divided by the new power, minus 1 power up divided by the new power. Here's my antiderivative. I'm going to evaluate it at x and 2. Okay, so I plug x in, minus, I plug 2 in. Okay, so g of x is x to the third minus x squared minus x. And what do I want to find? I want to find g prime of x. Well, when I find the derivative of that, it's 3x squared minus 2x. So we talked about that the other day. All you got to do is we just plug x in for t. And then technically, just like when we first learned different rules there, you know, especially the chain rule and whatnot, you got to take the derivative of x. What's the derivative of x? Just 1. That's why we don't put a times 1 right here. Okay, so let's try one more the long way. Then there's going to be a few that we really can't do this the long way. So again, here's g of x. All right. Now this is a good example because notice the bound, upper bound is not simply an x, it's an x squared. So we'll think about what that means. So last time with the quote long way here, if g of x is that integral, I'm going to first take the antiderivative, 1 power up divided by the new power, plus 1 power up divided by the new power. My bounds are negative 3 to x squared. So first off, I'm going to plug x squared in for t. Okay. Minus, and plug negative 3 in for t. All right, 2x to the fourth plus 2x squared minus 18. That is what g of x is. Now I'm going to take the derivative. It is 8x to the third plus 4x. Again, I can factor out a 4x there. Now, much quicker way, using the fundamental theorem, part 1. If g of x is equal to that integral there, then g prime of x, what I do is I plug x squared in for t, but I got to find the derivative of x squared. Just like that first example, the derivative of that upper bound, x is just 1, so I didn't write it. I plug x squared in for t, and I also have to find the derivative of that x squared. Just think of it kind of like a chain rule. If you found the derivative of sine 4x, it would be cosine 4x times the derivative of 4x. So multiplied by 2x, when I distribute, that's what I get, which is the same answer as I got up above. This way I do not have to find, I don't have to integrate and then find the derivative of something. I simply plug in my upper bound, whatever it is in terms of x, and then I have to take the derivative of that. All right, so no more long way. There's always one of these on the SIU Carbondale final. So I want to find g prime of x. G of x is equal to this. Integral 1 plus t squared, square root of that, dt, with bounds 0 to x. So g prime of x would simply be 1 plus x squared, plug x in for t. And then again, the derivative of x, my upper bound would just be 1. I don't need to put times 1 there. All right, that's it. That's what g prime of x is. Again, fundamental theorem of calculus part 1. If this break goes longer, then I will put up more videos on this section at a later date. Find, again, this is just like saying g of x equals this. Find g prime of x. I want to find the derivative of this integral. All right. So what I'm going to do is I simply plug x to the 4th in for t, because x to the 4th, when I take the derivative of x to the 4th, I don't get 1. I get 4x to the 3rd. I take the derivative of it. I just put it on the outside there in front as the leading coefficient. All right. Let's try another one. Example 5. Find the derivative of that integral. Okay. Using fundamental theorem of calculus part uno. I made a mistake here. Okay, it's got to be a different. If your bound is x, you have to have a different variable in there. Okay, so make that a t. 1 over 1 plus t squared dt. Plug x squared in for t. And then, because I can take the derivative of x squared and not get 1, I take the derivative of that x squared. And that is the derivative of that integral. Nice. All right, find g prime of x. There we go, g of x is that. I plug x to the 3rd in for r. I plug x to the 3rd in for r. I did my very best, making this my best handwriting possible. Plug x to the 3rd in for r, and then take the derivative of x to the 3rd. That simplifies to give you this. All right. Find g prime of x. G of x is the integral, x to 10 tan theta d theta. The upper bound always has to be x from what we wrote on Friday. So what you do, and we'll see this a lot, if you need to switch the bounds, then I can switch the bounds. It's just going to be the opposite integral now. We did that with the velocity. Well, we multiplied by a negative in the velocity questions earlier. So if I ever need to switch the bounds, and that's a trick of the trade there, I can switch the bounds. I'm just going to have the opposite then of that integral. All right? So I do that. That's the new one I'm working with. So what I do is I just plug x in for theta. The derivative of x is just 1, so nothing else is written. And g prime of x would be negative tan theta. Whoa. All right. Find y. And see, you needed that on that one because you know tangent is sine over cosine, but we haven't talked about u substitution yet, so we would not be able to find that antiderivative. All right. Find y prime if y is equal to this. Again, x is the lower bound. We got to switch that. So we do. We flip it. 0 is the lower bound. E to the x is the upper bound. So we have negative integral 0 to e to the x sine cubed t dt. Plug e to the x in for t. And then you have to take the derivative of e to the x which I forgot to do. All right, the derivative of that is definitely not 1. All right, my bad. There we go. Again, take the derivative of the upper bound involving x always, which I did not do. Okay, so it should have gone right there. The derivative of e to the x. All right. I believe the last example for section 5.4 part uno, part 2 is pretty easy. Find y prime. All right, again, you can plug something in for t in multiple locations. I'm going to plug square root of x in there, square root of x in there. Again, my term involving x is the upper bound, so it's all good there. All right, that's what I did. I plugged square root of x in for t, square root of x in for t. Then I have to take the derivative of the square root of x. You guys know x to the 1/2, bring down the power, 1 power less, that is the derivative of the square root of x. So the 2 would go in the denominator, and so would the root x. Root x times root x just gives you x. And that is your final answer. All right, I would like for that, looking ahead, yes, that is the last video for section 5.4 part 1. All right, I didn't get a lot of views yesterday during the day for these lessons, so folks, we need to get at it, okay? This might have to be the way you learn calculus for a little bit. Remember, SLU is not off, okay? SLU is doing distance learning, so whatever's happening at our school, your calculus and stats classes are still progressing. So if we have to learn new things via these videos, that's what's going to have to be. So get on it, folks. All right? This is Yak Math Videos signing out.